This is ASFurther Maths Pure, and we're on Unit 4, and we're looking at vectors. This is 4.7, the vector product, also known then as the cross product. So the scalar product, as you knew from a couple of sections ago, was A dot B equals modulus of A modulus of B cos theta, where theta is the angle in between the two vectors A and B. A vector or cross product of the vectors is defined then as A cross B is equal to modulus of A modulus of B sine theta n. Once again, theta is the angle in between the vectors A and B, and n is a unit vector perpendicular to both A and B. Whenever you find the dot product, remember you just kind of multiply the i's, the j's, and the k's together. You got a number out of it. With this, you get a vector out of it. The direction of n is that in which a right-handed corkscrew would move when turned from A to B. So see, as you turn here from A to B, it's a bit like, don't think about a corkscrew, but think about unscrewing a bottle. If you unscrew it this way here, it's going to go up, and that's then the direction then that it's going. Alright, so as you unscrew the top of the bottle, you guys know you're going to unscrew a bottle like that. Hopefully that makes sense. Turning it that way around, that means that the end's going that direction there. If the n is in the opposite sense, that is then from B to A, then the movement of the corkscrew is in the opposite sense to n. That is in the direction of minus n. So if you're kind of screwing it down, that would screw the top back on, if that makes sense. If you're kind of going that way there and returning kind of down that way, that would go that way. That means then that B cross A equals modulus of B modulus of A sine theta minus n, or if you want minus modulus of A modulus of B sine theta n. That's equal minus A cross B, and B cross A then is minus A cross B. So be careful therefore, because A cross B is not equal to B cross A. The vector product is not commutative. Notice that A dot B is called the scalar product of A and B. I mentioned this before because the result is a scalar, and that A cross B is called the vector product because the result is another vector. It's very useful further on in this unit if you can find a vector perpendicular to two vectors, and that's what the cross product gets you. It gets you a vector perpendicular to the two vectors. Now the vectors I, j, and k are such that each one is perpendicular to each other. Also, the relative positions are such that if a right-handed corkscrew were turned from I to j, so if we're turning it this way here, it would give us k. You should also be able to see if right-handed corkscrew is turned from j to k, you get I, and if it's turned then from k to I, you would get j. So I cross j equals modulus of I, modulus of j, sine 90, because they're obviously 90 degrees apart, times by k. 1 times 1, modulus, the size of this vector here is 1, this is 1, sine of 90 is 1, 1 times 1 times 1, so it gives you k. So I cross j is k, j cross k is I, and k cross I is j. If you keep them in the right order, I, j, and k, it generates the right thing. So ij is k, jk is I, and then ki is j, kind of all these going that way there. Also, since the angle between I and itself is 0, and sine theta is 0, then I cross I is 0, j cross j is 0, and k cross k is 0. The vector product of two vectors, so this is a general form again, it's one of these things that's much easier whenever you see it with actual numbers, but a1i plus a2j plus a3k and b1i plus b2j plus b3k, we're doing the cross product then of each of these. So we have actually 9 things to multiply out with: this times these 3, this times these 3, this times these 3. So it's going to give a1 b1 I cross I, and of course remember I cross I gives you a 0, so it's going to disappear. A1 b2 anyway, and you go through all of these 9. So let's see how it tidies up, hopefully slightly over the page. Yeah, sorry, we'll go back actually. J cross j, sorry, I cross j, that's going to turn into a k. Can we see that? So an ij is going to turn into a k, and then an ik, that's a backwards one, that's going to be then a minus j. And so once you multiply all these things out, they start to tidy up a bit. So here's what we had again. So that's the third set, and so we end up then with a1b2k plus A1B3 minus J plus A2B1 minus K plus A2B3I plus A3B1J plus A3B2 minus I. Alright, tidying it up then, we get A2B3 minus A3B2I plus A3B1 minus A1B3J plus A1B2 minus A2B1K. If you're still with me, you're doing well. The deal is there's an easier way, and if we remember our rules from matrices, if you're to find the determinant, if you remember, we go I upon then the determinant of these four, minus, you always remember the minus J upon the determinant of those four, plus K upon the determinant of those four. Actually, that finds the vector product for you. So that's the way of doing it. You stick an ijk on the top, you stick the first vector here, the second vector here, and that generates exactly what you need. So A1I plus A2j plus A3k plus B1I plus B2j plus B3k. Whenever you're finding the cross product, it's the same as the determinant, ijk, with the first vector, the numbers written here, second vector, the numbers written here. If the vector product is equal to 0, if A cross B is 0, then since A cross B is modulus of A, modulus of B, sine theta n, then either this one's 0, or this one's 0. So, but if either theta is 0 or theta is pi, then A and B are in the same direction, and either in the same sense or in the opposite sense. In either case, if sine theta is 0, then A and B are parallel. So if A cross B is 0, then either A is 0 or B is 0, and A and B are parallel. Okay, so example 1 then, as we're chatting about, evaluate this. So you could sit and multiply out each of these, and there are the 9 things to multiply out, but our definite plan is to find the determinant. So how do we set this up? We do an I, a J, and a K here. We get the first one, which is going to be 1, minus 2, and 5, and the second one, minus 2, 1, and minus 3. So how's your memory? It's going to be I upon 6 minus 5. Do you see that okay? So that's going to be 1. Minus J. Do you remember the minus okay? I hope so. Again, the two outside ones. So that's a minus 3 minus minus 10. So that's going to be a 7. Plus K. And then that's going to be 1. And then that's going to be minus 4. So I think then that's going to be a minus 3. So what do we find? We find our cross product. Remember, a cross product gives you a vector, not a number. And the vector that it gives us then is I minus 7j minus 3k. And what we've actually found there is a vector that is perpendicular to both this one and this one. Example 2 then is just the same, just be careful of the i's, j's and k's that are missing. So we set it up, we're finding the determinant I, j, k. Our first one then is 3, 0 because there's no j term, and then minus 2, and then there's no I term here, and then it's a 1 and a 3. So what's that going to give us? That's going to give us I upon 0 minus minus 2, so I think that's a 2, minus j, 9 and 0, 9 plus k, 3 and 0, so that then will going to be a 3. So the vector product then of these two is 2i minus 9j plus 3k. Alright. Example 3 is reasonably similar. Find the unit vector which is perpendicular to both this one and this one. So same format, let's find our vector product. That's going to give us a perpendicular vector, and then we can change it into unit vector easy enough. So we have I, j, k, 2 minus 1, 3, and then minus 1, 3 minus 1. So our determinant then in this case is going to be I. 1 minus 9, I think that's minus 8, minus j, minus 2 plus 3, so I think that's a 1, plus k, 6 minus 1, so that is going to be 5, so our vector's parallel is minus 8i minus j plus 5k. We need to find then the length of this vector, so that's minus 8, so you go minus 8 along the x-axis effectively, down 1 if you want, and out 5, whatever way you want to think about this, but we're going to find then the modulus of this, so it's going to be minus 8i minus j plus 5k, and the way we work that out is obviously going to be the square root of 8 squared, which is 64, plus 1 plus 25, and that gives us then the square root of 90. Therefore, the unit vector that we require is equal to minus 8i minus j plus 5k all over the square root of 90. That'll be fine to leave your answer like that. Might want to do then 1 over root 90 minus 8i minus j plus 5k, or again if you wanted minus 8 over root 90i minus 1 over root 90j plus 5 over root 90k, and that would work it out for us. Example 4 then, find the sine of the acute angle between this vector here and this vector here. We're going to use our cross product then for that. To be honest, it's easier using the dot product and then finding the cos of it, finding the angle, and then just find the sine of it. But we're in the middle of our cross product here, so let's keep practicing then with that, and at least kind of show where this is coming from. So our formula is sine theta n. So let's find our cross product. I, j, k, and 2 minus 1, 2, minus 3, 4, 1, and that's going to be I, and upon minus 1 minus 8, so I guess minus 9, minus j, 2, 6, that's 8, plus k, you can still see here, 8 minus minus 3 is a bit different than what I have here, so let me see, sorry, k, it is 8, yes, take away 3, sorry, so that's 5, that's alright. So our vector then is going to be minus 9i minus 8j plus 5k. So how we're going to use this, we now have this vector here, so we're going to find the modulus then of that one. So our modulus of A cross B, of course, is going to be minus 9 squared plus minus 8 squared plus 5 squared. If you work that out, you get the square root then of 170. So then rearranging this and setting it up is going to be, no, in fact, you know what, we'll substitute into this first of all. So our modulus of A cross B is going to be square root of 170 equals then modulus then of A. So where is our A? It's 2, 1 and 2. We can do that, can't we? So it's 4 plus 1 plus 4, so it is the square root of 9. We know that one. Then our other one is 3, 4 and 1. Obviously it's a minus 3, but it doesn't make any difference. You're 9 plus 16, so it's going to be then 26 times your sine theta. And because our n is a unit vector, then we can just take that then to be a 1. So we're quite close. So sine theta is the square root of 170. all over 3 root 26, and I'm told that that tidies up very slightly to give me the square root of 85 dividing obviously top and bottom by root 2, 3 root 13.